Okay, so this video is going to be about transformations, and it's going to be a transformation which is called an enlargement. Now, an enlargement will change the size of the shape either larger or smaller. An enlargement usually means make bigger, but in the case of mathematics, an enlargement is just a change in the size. So you can make it larger with a positive or a number bigger than 1, or you can also make it smaller. In that case, then the enlargement, the scale factor, would be smaller than 1. We'll talk about that a bit later. So to specify the enlargement with, first of all, a scale factor, which is how much bigger you make it. And then secondly, a center of enlargement. So similar to the rotation, you need to have a center that you're going to carry out the enlargement. And there's one other thing to note, is that the scale factor can be negative, which will flip the shape. So if you have a negative scale factor, what happens is the shape ends up flipping like you've reflected it. Now let's explain how this is going to work. So here I have a shape here on the grid again. So what I'm going to do, I'm going to select the shape. I'm going to take the center of enlargement and I'm going to move it over here to the center there. So I can see here that it's showing me a scale factor of 1. So when it says scale factor 1, this means it's the same size as it was originally, which is not surprising because I haven't moved it. Now if I drag the tool a bit further away, I can see that it gets larger. And if I get scale factor of 2, then I can see it's basically twice the size it was before. So along here, it's now 2 squares, and along here, it's now 4 squares. Whereas at the beginning, it was here 1 and here 2. So a scale factor of 2 means it will be twice the size. If I put it back where it was, which was a scale factor of 1, here somewhere. I don't know, because I've done a rechange. So because I stopped where it was, so it would have taken the original one as now big, so back where it was would be now a scale factor of a half. So it's half the size it was just now. So that's why scale factor is a half. That's where it started originally. And then I can make it even smaller. And if I go to scale factor like 0.25, it will be a quarter of the size it was at the end, or half the size it was originally. And you can see it's get closer. So you can also see that as it gets smaller, it gets closer to the center of enlargement. And as it gets bigger, it gets further away from the center of enlargement. Now, if I move it so the scale factor becomes negative, what happens is that it will end up being on the opposite side of the center of enlargement, but the same size it was before. So if I go over here to where it says scale factor 1, minus 1, like that, then that would be the same size as it was when it was over there up in the top right-hand corner. Now it's just flipped over and it's reversed. So when you have a negative scale factor, you end up on the opposite side of the center of enlargement than you were originally. So if I flip back over here again, scale factor is 1. It's up here on the top, and then if I have the scale factor of negative 1, then it's over here on the bottom. All right, closer to the center of enlargement will be smaller, and further away from the center of enlargement will be bigger. So that's basically how it works there. I can undo that, bring it back where it was at the beginning. Okay, so it's there. Now, if I try that again, and I just move my center of enlargement, or leave it where it is by default, it's in the center of a shape. Now, if I make it bigger, you can see that the points all move away from the center of enlargement, but because the center of enlargement is between them, it ends up bigger, but in a completely different place to where it was before. So the scale factor is still the same. If I have a scale factor of 2, it's double where it was when I started. If I have a scale factor of 3, it'll be 3 times where it was when it started. If I move it over here so that you've got a negative scale factor of negative 3, then each point is 3 times the distance it was before, but on the opposite side of the center of enlargement. So I need to specify my scale factor, positive or negative. I also need to specify my center of enlargement, and then I need to specify how much larger it is with the scale factor. Okay, that's how enlargement works. So what I should do now is explain how we can actually work that out. So say I have my shape here without using the tool, and I want to enlarge it by, say, scale factor 2 and with a center here, like that. So what I do, this is my center of enlargement here, and I consider each point in turn how far away it is from the center of enlargement. So from the center of enlargement to get to this point, I need to go left 1 and up 2. So if I doubled that, because my scale factor would be 2, I would, instead of make this 1, I would make it 2. And then instead of going 2 up, I would go 4 up. So this point would become here. Then this point here, From the centre of enlargement would be 2 to the left and 2 up, so I would double that. It would be 4 to the left and 4 up. So this point would become here, like that. And this point that's at the top here, from the centre of enlargement, it's 2 squares to the left and 4 squares up. So this would have to be double, so it'd be 4 squares to the left and then 8 squares up, which would be up there. So my new shape, my enlarged shape, would be there, like that. So that would be, as with the centre of enlargement here at 8, 0. So I've counted squares when I was doing it, but the scale here is actually 2, or 1 square is 2. So this point here would be 8, 0. The centre of enlargement would be there. So the centre of enlargement there with a scale factor of 2, my triangle would appear up here, like that. Now, say I wanted to use the same centre of enlargement with a scale factor of -2. So what I would do is I would take this point here, which was 1 square to the left, 2 squares up, and I would do the same, double the distance, but in the opposite direction. So with a scale factor of -2, I would go 2 to the right, and then 4 down would be here. And then likewise with this point, 2 and 2 would become 4 and 4 would become here. And the point at the top up here, which was 2 and 4, would become 4 and 8 would appear down here. So that point there. So this one here was with scale factor 2 and the centre 8, 0. Whereas this one down here was with scale factor -2 and again centre 8, 0. That's all well and good. Now, if you want to say you wanted to work out where, say you had this green triangle here and this red triangle here, you wanted to work out where the centre of enlargement is, what you can do is do things in a different way. And what you do is you join up the equivalent points, and where they all cross should go through the centre of enlargement. So this point here is equivalent to this point here. So I join those up. This point here is equivalent to this point here. I would join those two up, and this point here is equivalent to this point here. So I would join those up. What's gone wrong here? I've done that, something's not quite right. Oh, I've done my red triangle wrong. It should be 1, 2, 3, 4. Yeah, okay. Red triangle should be down here instead. So that's a good check to do that, so I can see that I've done something wrong. It should be there. Let me fix those other ones. That should be gone. That should be gone, and I can delete that out. Okay, so, oops, I've rubbed out that line. All right, so my red triangle was here, and then when I join up the equivalent points on the triangle, they should all meet through the centre of enlargement. So if I just had the two triangles, I didn't know where the centre of enlargement was, I would be able to do that, work out where the centre of enlargement was, and I could then measure the side length here. This is 1, this is 2, and I could be able to see that the scale factor was 2. So by doing that, if you've got the two triangles, you can work out where the centre of enlargement is, work out what the scale factor is, and if you've got the scale factor and the centre of enlargement, you can work out what the enlargement is. So remember, when we have an enlargement, you have to specify the enlargement with a scale factor and a centre of enlargement, and remember the scale factor can be negative, which will flip the shape. So that's why the red one here is oriented the other way round to the green one, because it had a negative scale factor here. Okay, so let's finish everything off by looking at a question. So it says triangles A and C are drawn on the grid below. So we've got our triangle A, our triangle C. I have to scroll down so we can see what's going on here. Then it says triangle B is the image of triangle A after a reflection in the x-axis, followed by a translation of 2, -1. Okay, so we've got to do two things here from starting with triangle A to work out where triangle B is going to be. So first of all, we're going to have a reflection in the x-axis. So the x-axis is along here. So that's going to act as my mirror line. So what I'm going to do is move each point equidistant on the other side of the mirror line. So this point will become here, this point will become here, and this point up here, 3 away, will become 3 away down here. So after the first translation, my triangle is going to look like that. Then, that's not triangle B though. To get triangle B, I've got to do a translation of 2, -1. So that's going to be 2 to the right and then followed by 1 down. So for each point, I'd have to move it 2 to the right, 1, 2, and then 1 down. So this point here would end up here. This point here, 2 to the right, 1 down would end up here. And this point, 2 to the right, 1 down would end up here. So what I'm going to do is I'm just going to move the whole thing 2 to the right, 1 down. There. So my triangle B should be there. Okay, that's what that says. Draw and label triangle B. So there it is. Then it says, describe fully the single transformation that maps triangle A onto triangle C. And we've got 3 marks for that, so we're going to have to explain things carefully. So the first thing to do is to look at the 2 triangles. And we can see that they're oriented differently. This one is rotated around, so we might think that it's a rotation, but we need to also notice that they're different sizes. Triangle C is bigger than triangle A, so therefore it has to be an enlargement. The only way you can change the size is with an enlargement. So what we're going to need to do is to join up the equivalent points on the triangle, so we can work out where the centre of enlargement is, and then we can use that to help us work out the scale factor as well. So I join the 2 corners, then I can join the 2 longer tips, and then I can join the other points, and I can see that all 3 of the lines pass through 0, 0. So my centre of enlargement is the origin, and then I can measure how big the enlargement is by this side here is 1 square, this side here is 2 squares. So it's twice the size, but because it's on the opposite side of the centre of enlargement, it's going to have to be scale factor of -2. If it was scale factor of 2, my big triangle would be up here somewhere. So because it's on the opposite side of the centre of enlargement, it's flipped around the other way, it's going to have a scale factor of -2. So my scale factor is -2, my centre of enlargement is 0, and it is an enlargement. So I'm going to say all of those things. So I'm going to say enlargement, scale factor -2, and the centre 0, 0. And that would answer the question.